Good day, everyone. Welcome to Learn at Home live session. I am Mr. Odunlami. I'll be taking you through mathematics, specifically latitude and longitude. In this session, we are going to treat latitude and longitude. I'm going to be introducing the topic to you. We're going to be talking about the uses and the importance of longitude and latitude, a performance objective. I'm going to explain to you what you actually need to know in this topic. The lesson discussion. We're going to talk basically on things around the world, places around the world. We're going to have a session break. I'm going to take questions from you, and we're going to answer after a short break. In case you have a question during the session, please feel free to send it in the forum. There is a space for you to do that, and then we're going to have a closing session. Now, you're going to learn today how to locate points on the surface of the Earth. That is, every point on the Earth is located by two lines, which is the longitude and the latitude. Using those two lines, we are going to find a way to locate points, different points. When we say points, we can mean a geographical area, we can mean a particular object on the spot on the surface of the Earth. And then we are going to learn to draw diagrams. The diagrams here are the foundation of solving problems. That is, using them to find the distance between 2 points, basically, using them to find the speed in which you can move between 2 points and the time it will take you between a particular point and the other. And then we'll find the difference in latitude and the longitude, which is going to help us to find the angle. The difference in latitude and longitude is what actually we use in the angle, and that's what we use in calculations. Now, let's hit the ground running. A latitudinal line is a horizontal line drawn across east, west, and so it goes round the circle. It's like cutting an orange horizontally. And so we measure this from 0 to 90 degrees from the equator, which is the center of the Earth, down to the North Pole. And so this is an example of what I'm talking about. We use this line to represent the equator, which divides the circle into two equal parts. Now you'll notice my broken lines. The broken lines is just to signify that this shape I'm dealing with is not a plane shape and is a three-dimensional shape. And so this looks like a sphere, and that is exactly how the Earth looks like. So this is the center of the Earth. We call this the equator, and the equator has an angle of 0 degrees. If you're comparing this with the plane geometry that we have, length in basic level, we can say this is 0 degrees. And when you move a bit up, we can call this angle 40 degrees. And that's exactly what we are dealing with. We are now bringing the plane geometry onto the three-dimensional geometry. And so moving upwards towards the north, we call this 40 degrees north. And so if you bring this exactly back here, this time around, we're going to draw latitudinal lines to represent the angle, and this is 40 degrees north. And so this is an example of latitudinal line. This is the smaller circle formed with a latitude. And so when we move upwards towards the north, further away from 40 degrees, we can call this angle 70 degrees north. And so it keeps going until we get to 90 degrees. 90 degrees is exactly on the North Pole. And so In like manner, we can move downwards. Moving downwards, we have the same pattern, but this time around, we are moving in the opposite pole. So this can be called 40 degrees south. And then if we move more downwards, we can call this 70 degrees south. And then when we get to 90 exactly, this is going to be the south pole. And so these are latitudinal lines. Each of these lines represents the particular area cut by the line. And so it is easy for us to do this one after the other. We are just using this like the x-axis. When we draw the x-axis, it's just horizontal. And so since the earth is spherical, our horizontal line becomes something like an arc. But always see this like the x-axis. And hence, longitude now. Longitude is a line drawn from the North Pole down to the South Pole. Now, in this case, the longitude is always from the north to the south, unlike the latitude, such that the lines can shift. For longitude, the lines do not shift. The starting point is always from the North Pole down to the South Pole. It can only drift towards the west or drift towards the east, but it's always starting from the North Pole to the South Pole. And it is usually between 0 degrees and 180 degrees. 0 degrees and 180 degrees. And so we can see the longitude as the y-axis. The longitude, we can see it as the y-axis. We can have, of course, our equator, which is the 0 degrees. And then the latitudinal line, like I said, from the north down to the south. This is what we call the longitudinal line. So if I need to draw another longitudinal line, I'll start from the north again, down to the south. And it keeps going like that, down to the south. I could call this 100 degrees west. I could call this 150 degrees west. The reason why I'm using west is because, of course, we know that the west is on the left part and the east is on the right. And so we can call this 175 degrees west. And so moving down to the east, we move this way, right side. We can call this 50 degrees east. And so for clarity purpose, it is understandable if we write the angles outside. 50 degrees east. We're moving eastward, but 50 degrees. And so if we move further away from 50 degrees, we're going to have another angle. It has to be greater than 50. And so we can say this is 70 degrees east. And it keeps going like that. So when we connect the longitude and the latitude together, we're going to get points. Normally, how we connect our x and the y axis. Okay, so now the prime meridian is actually a longitudinal line, but it is the point in which it's called the starting point from which every other angles are located. Now, the prime meridian is 0 degrees. And on the surface of the Earth, London the prime meridian is a longitudinal line, of course, from the north down to the south. Equator should be drawn, and the center of the Earth should be located. Okay, so the longitudinal line is from the north down to the south, and the prime meridian is 0 degrees, which is located in England. Now, using these 0 degrees, we can now find every other longitudinal line. And so if this is 0, we can say this is 100 degrees down to the west. And this is 150 degrees down to the east. So that's what we call the prime meridian, 0 degrees. Okay, so by combining the latitude and the longitude, we can locate any point on this Earth's surface. Any point that is a particular position in which an object is, or a particular position in which a house or a company or any particular thing is, and which help us in GPS locationing system, GPS positioning system. Okay, so now let's connect the latitude and longitude together. This is the equator, 0 degrees. All right, so let me draw the prime meridian. This is north, this is south, and this is the prime meridian. Let's call this 0 degrees. Now, there is a point of intersection. This point of intersection is the particular point in which we are talking about. So when we have a point A having 50 degrees north and 10 degrees west, this is how we locate this point. Of course, the latitude always comes first, like the x-axis comes first. Then the longitude comes second, like the x and the y. Now, to locate this point A on the spherical shape, we have 50 degrees north. It means we're moving from 0 degrees down to the north, 50 degrees. So we draw our latitudinal line first. Let's call this 50 degrees. Okay, now our longitude, 10 degrees west. We are going from the prime meridian, which is 0 degrees, down to the west. Okay, so the west is usually to the left. And so we can call this 10 degrees. For clarity's sake, we can draw our line and locate the point outside the sphere and call this 10 degrees west. Okay, now, this is the latitudinal line we drew, 50 degrees north, and this is the longitudinal line drawn. So the particular position we are talking about is the point of intersection. And so we can place A. This is point A. This is exactly how we locate points. Let me do another example. We want to locate another point on the Earth's surface. We want to locate points 40 degrees north and 30 degrees west on the Earth's surface. As you can see, we have the North Pole, we have the South Pole, we have the East, and we have the West. Each of those lines have their angles. And with those angles there, it is easy for us to track our angles, 50 degrees, 60 degrees, 70, and 80. Let's locate points 40 degrees north and 30 degrees west. The major things that are to be represented are the equator, the north, and the south pole. Those are the major things that need to be represented. We don't need too many lines, except for the lines that signify the point you are talking about. Okay, so when we're talking about 40 degrees north and 30 degrees west, this is a particular point. Let's call this point Q. Point Q. Our latitude is 40 degrees north. We are going towards the north, 40 degrees. Okay, so we move close to the top. This is 40 degrees north. That's our latitudinal line. Now it's time to draw our longitude. 30 degrees west. This time around, we don't need to draw our prime meridian, 0 degrees. The prime meridian can be assumed to be anywhere. But what we need to make sure of is our west is going towards the left and our right is the east. And so 30 degrees west, we go towards the left. And so always remember that the longitude always go from the north to the south, always. Okay, so now the point of intersection is very glaring. And we can see that there's a particular point where the longitude and the latitude intersect. That point is called point Q. And so this is the point we are dealing with. All right, now there's what we call the difference in latitude and longitude of points. The reason why we find the difference in latitude and longitude of points is because we need to find the distance between 2 points. The way to find the distance is by using the angles. Now, if we have point Q and we have point W, let's locate W still on the same diagram. Point W, let's call point W 30 degrees south and 30 degrees west. 30 degrees south and 30 degrees west. Don't forget latitude, longitude. Latitude first, longitude next. Okay, so the first one we're going to draw is the latitude. 30 degrees down to the south. This is 0 degrees. We're moving towards the south, but 30 degrees. So we put it somewhere not far away from the 0 degrees because it's not up to 45. Okay, so we have 30 degrees south. That's our latitudinal line. Then our longitudinal line, 30 degrees west. Let's locate 30 degrees west. It's already drawn from the diagram. It's already here. We don't need to draw another line. Let's take note of this. We don't need to draw another line since we've drawn the 30 degrees west previously for Q. So we use exactly that same line, and hence the intersection is glaring. This is point W. So we have point Q and point W. In that way, we can find the distance between these 2 points. Now, let's go straight to finding the difference in latitude. I just told you the reason why we find the difference in latitude, because we have 2 points or 3 or 4 such that we want to find the distance. Now, let's find the difference in latitude and longitude. From the diagram, I can denote my points. Q is, the latitude is 40. The reason why I claimed it is sometimes you'll be told to interpret the diagram instead of drawing. Sometimes reverse will be the case. And so it is essential that we learn how to draw and we learn how to interpret the diagram. Okay, so we have the latitude, 40 degrees. That's what we're going to write first. And then the longitude, 30 degrees west, which is going to be written. Then we have point W, which is the latitude, 30 degrees south, and then the same 30 degrees west. So we want to find the difference in latitude and longitude. Difference in latitude and longitude. There's a basic law of electromagnetism which states that like poles repel and unlike poles attract. Like poles repel and unlike poles attract. So it means that if we have any pole that are the same, what we do is we subtract. And if we have poles that are different, like the north, the south, the east, and the west, we are going to add. And so difference in latitude will be equal to, from here, the latitudes are the first ordinates. 40 degrees north is the first latitude for is latitude for Q, and then 30 degrees south is the latitude for W. And so to find the difference in latitude, the poles are different, north and south, and then we add. So we have 40 degrees plus 30 degrees. This finally gives us 70 degrees. That's what we call the difference in latitude. Don't be confused. Difference in mathematics means subtraction, but under this, there must be a protocol for either subtracting or adding. Because in mathematics, when we say sum of two numbers, we can also say the sum of a positive number and a negative number. It now depends on the sign that comes between them. All right. So if you're talking about the difference in longitude, remember I said like poles, we subtract. This is west and this is west. And so we are subtracting. 30 degrees minus 30 degrees finally gives us 0 degrees. That is how to find the difference in latitude and longitude. Okay, an example is here. Find the difference in latitude of the points below. Point P, 50 degrees north, 100 degrees west, and point Q, 30 degrees south, 13 degrees west. To find the difference in latitude of the first set of points, we use the same formula. Note, the same direction, add. Different direction, subtract. We have the same direction, add. We have the same direction, rather, we subtract. Then different direction, we had. Okay, so for the difference in latitude of this point, we have 50 plus 30. Why are we adding? Because the directions are different. So we have the north and we have the south. The directions are different, so we're going to add them together. 50 plus 30 is equal to 80. And then also for points A and B, 42 degrees south and 20 degrees south, we are going to subtract this time because the poles are the same. And then we have 42 minus 20. Okay, now the difference in longitude of the same set of points, 50 degrees north, 100 degrees west, and Q, 30 degrees south, 13 degrees west. We're going to subtract these longitudes because the longitudes are the same direction. As you can see, point P have longitude of 100 degrees west, and point Q has longitude of 13 degrees west. All right, so to subtract this, we have 100 minus 13. 100 minus 13 is equal to 87. And then for the longitude, between the difference in longitude between A and B, we have 105 degrees east, we have 15 degrees west. Since we have east and west, we are going to add because they are different poles we had. All right, so we have 105 plus 15. This gives us 125. It gives us 125. I'm glad that you've sent your questions. We're going to answer them shortly. Write out the coordinates of A, B, and C. The coordinates of A, B, and C. Now, the diagram has been given and the points have been located. But we need the coordinates of each of those points located. All right, so we have 30 degrees north, 30 degrees west. Point C has a longitude of 60 degrees west, and then point A has a longitude of 0 degree. Okay, apparently, point A is actually on the prime meridian. All right, so the coordinates of point A, usually written like this: A, open brackets. We write the latitude first, then the longitude. The latitude of A is 30 degrees north. So we have 30 degrees north. The longitude of A is 0 degrees. 0 is neutral, so we don't need to add any pole. We don't need to add either the east or west. It doesn't matter. It is neutral. All right. So the coordinates of B, written in like manner, will give us latitude first, 30 degrees north, and then longitude, which is 30 degrees west. Finally, point C. Latitude is 60 degrees north, as indicated. 60 degrees north. So writing the latitude first, we have 60 degrees north, and then the longitude, 60 degrees west. This is the full answer to the question. The coordinates of these points, A, B, and C. The coordinates of A, B, and C. That's how simple it can be. We have come to the end of this session. So thank you for attending today's session. For further reading and reference, select longitude and latitude in this lesson content available at learnathome.ng, and join us again next week, same time, for another exciting session.